Awesome. Okay, let me share my screen. There we go. Can everybody see my presentation? Yes? Cool. Awesome. Okay, so like Lauren said, my name is Samantha Roberts. I am a research director here for CETA, um, the Center for Innovative Design and Analysis. And today I'm going to be talking about basic data management, R. Um, so thank you so much for joining me today. So our agenda today, we're going to talk about what is R and then how to install R in RStudio. Then we're going to discuss kind of the type of objects and operations in R. We are going to discuss different importance of coding and some kind of tips and tricks on how to code. We're going to talk about packages and how to install them. Those are important aspects to R. I'm going to show you how to import data, how to conduct some data summarization, as well as variable creation and transformation, and then how to create and export a clean data set. So to start off, what is R? So R is a free and open source software for statistical computing and graphics. Is based on the S language. And I recommend that you actually download a companion called RStudio. It's just an easier and more user-friendly environment for coding in R. So here are some of the instructions on how to download R. So you would go to this website, which I will show you in a minute. You'll click on a download R. You're going to choose a mirror that's closest to you. So it's sort of like a location. So you'll look into the US and I'll show that. And then you'll pick either Windows, Mac, or Linux. And then so you have to download R first before you can download RStudio. You will follow this link. You will choose RStudio Desktop. It's free. And then you'll pick which system that you would want to install. So let me show you what that looks like. Here we go. Okay, so this is that first link. This is how you download R. So you would click this download R here, and then you can see here we have all of these mirrors in all of these different locations. So you have Argentina, Australia, so you can obviously download this anywhere. And so here you can go down to USA, and these are kind of the different locations. I think when I did this, I picked Oregon State. So you would just click on that link, and then you would download here for each one of your whatever system that you have, right? So I have Windows, I would say download, and then I would click that to install R for the first time. For Mac users, you will have to download this R Quartz program before you could download R. And then for RStudio, you would go here and you would click this download RStudio, come down here to RStudio Desktop, download RStudio, and then you would install, first you have to install R, then RStudio for desktop. And these are the different kinds. So you could do Windows, Mac, what have you. So that is how you would download R. Is there any questions on that process? Awesome. So if you do have any questions, you could put it in the chat, or there's going to be, 15 minutes at the end for questions. Okay. So, oops. Okay. So now I want to talk about different data objects in R and different operations that you can use in R when you're coding. So in the objects in R, vectors, lists, matrices, arrays, factors, and data frames. We're mostly going to be dealing with in this is talking about vectors, factors, and data frames. So vectors are one of the basic programming data objects in R. There are 6 types: logical, integer, character, raw, double, and complex. Factors are data objects that are leveled or categorical. And then a data frame is a 2-dimensional data structure where you have, variables in columns, and usually kind of when we're talking about medical data or healthcare data or survey data or electronic health record data, patients are participants in the row. Um, so like we talked about, there could be numeric values, integer values, logical, which is true, false, character or string values, and dates. Um, and then here are the different operations that you can do in R. I'm not going to go into explicit every single one of these, but we will be using these when we do variable transformation and creating new variables. So we have addition, subtraction, greater than, equal to. A main one here, and I'm going to say it again in the next slide, is how you assign value to an object. So if you've used SAS or Python, it's a little bit different. Here we use an arrow, not an equal sign. So if we want to say like A equals 2, it would be A arrow 2. And I will show you that when we get into that part of the presentation. Okay, so I just want to give a little bit of like general information on coding, on how to code, and then also some little tips in how to code in R. So in general, when you're coding, is you're implementing different steps or actions that you want the software to make. So a big thing that you want to do is that you make sure you do the steps in order. So you don't want to start analysis before you have clean data or before you create the variable in the way that's most useful for your analysis. And sometimes a lot of this can get really, really long, right? You're coding, you can have, hundreds to even thousands of lines in code. Do portions at a time. So you don't want to write a whole big long code and then run everything, and then you have all of these arrows pop up and then you don't know where it comes from. It's easier to do a little bit at a time, know that it's correct, and then add to your code as you go. This works in SAS and Python and kind of any coding environment that you're using. Especially with data management, you want to check that what you're doing, like what you're coding, is actually what you think it's doing, right? So if you're creating, for example, like a BMI category, you want to make sure that the numeric value of the BMI matches what you're trying to make the category be, right? So if you're saying BMI is less than 18.5, but you coded it wrong and somebody with a BMI of 19 is considered underweight when you really wanted it to be 18.5 or below, you want to be able to check that. So this is why I always say, go through and check your work, make sure that the variables that you're creating or whatever you're trying to do, you're actually doing it. A big thing with variable names is you want to have short, concise variable names and also have it being an indication of what the variable is. This also works if you create like a red cap database, right? This is really important. You don't want to just name your variables or your questions like variable 1, var 1, var 2, because when you come back to it a week later, 2 weeks later, a year later, you don't really have an indication of what that variable is. So for example, if you have a height variable, labeling it height or shortened HT is really, really good. Or for example, blood pressure, BP or blood_pressure. So again, so you have an idea of what exactly is this variable and what is it, what am I trying to show here? And then a big one is always comment out what you're doing. So as you're, doing data management, data analysis, if you're bringing in different data sources, you want to comment what you're doing and why you're doing it. So again, if you come back to it a year later, you can be like, oh, okay, I know what I'm doing here. I know the goal of this. So for specific tips in coding in R, again, this is talking about in the script layout, which we'll go over, but making sure that you're doing things in order. So for example, like libraries, whatever libraries that or packages that you need, you want them loaded at the very beginning. You can't load them at the end because your script won't work. Um, Again, to bring it up again, oh, sorry guys, you want to use an arrow, not an equal sign. And within R, case matters, right? So uppercase and lowercase are different. So for example, if you put something as HT, capital HT is not the same as lowercase ht. Those are considered two different variables. So making sure that you are using the correct case when you're doing manipulation with data with the variables is also really important. And then just break up the long lines of code, kind of coming back to what we said over here. If you have a long chunk, like if you're commenting out, you'll be able to see everything a lot better. Okay. So now we are going to go to, oh no. The one thing I forgot to open is my actual code. Here we go. Okay. Sorry about that. So I will share now. Okay. So when you download RStudio, this is what you are going to see. And all of this material, so this presentation and all of this R code is available on online. We can attach the link to the chat if that would be helpful for later. But here are the different sections within R. So right here that I'm pointing to here, where you can see all this code that I've done, this is the script. So this is where you put in your code. This is what's saved when you save the code to your computer. This is what's saved. This down here is your console. So anything that you write in here will show up here at the console. And also any of the results will also show up here in this console. This environment, the environment shows all of the variables that you've created, the data frames that you've created, data sets that you've imported in, all of that here will be in the environment. And then over here on this left side, and then there's also like history, things that you've done, connections, tutorial, which we're not going to really get into. Honestly, I've been using R for a long time and I rarely use those tabs. Over here, this is actually super helpful. So here is the files tab where you can get access to any of the files on your computer. So this is the way that you can kind of see or where you're going to save things when you do plots. So if you come to the data visualization course, you'll see that your plot will show up here. Packages, which we're going to talk about. This is all the packages that you can install or upload into your program. Help. This is super awesome. If you have any questions about like what a package is or what a function is or how to use a function, you could do a question mark with whatever the function is, and that information shows up here. I'm going to show you multiple examples of this as we go through. Viewer, this is if you create a table or something, this is how you can view it, which we will see later. Okay. So let's get into it. Let's look at these kind of data types that we've talked about. So here I'm going to want to create a character variable. And so I'm creating this X variable here. I use my arrow and I'm making it to be hello world. And then if I just put this X here, when I run this, it'll just show the result. So there are multiple ways that you can run your code. So one way is you can just put your cursor here and click up here where it says run, and you just do it. And then you can see here in the console how it said it shows what you did. And if we want to see what X is, we can click the run again, and we can see that it says hello world. Say you want to do both of them at the same time, you can highlight them, press run, and then it shows you, right? Here's what I created, and then here's the result of that. You could also, what I like to do, and I didn't find this out till a lot later, but it makes it easier to do this kind of coding in R, is actually you can, again, highlight or just kind of put your cursor anywhere and use Control Enter. And then that runs the code, Control Enter, that does it again. So here we can see we made a string or a character variable, and this function called class, or the statement called class, allows you to, if you weren't sure what the data type was, you can do that with any variable. So class, you can see down here in the console, this is a character, right? So here, now I'm going to create a numeric one. So I'm going to create the variable, see what the result is, and make sure that, is it a numeric? Yep, it is a numeric. So here, I really want this logical, right? I want to say that this is a true false statement. So Again, I'm going to create this variable b. Now, if I'm going to create a variable that has multiple, so instead of just one where we had just hello world, I want true and false. You use this letter C, and then in parentheses, you have whatever you want to put first, comma, second. So that goes with any coding in R. If you're going to code something to one thing, but there's multiple things in it, this is how you do it. So here we can say, okay, looks true, false. It has parentheses around it, but this is a character variable and I don't want it. So now I can change this to be logical with this statement, as.logical with whatever variable you're interested in changing. So you can see here, we can run this all again. So you can see the output, it goes from having parentheses around it to now being a true false. So this will be helpful when you're doing kind of like some data analysis that having it as a logical true false versus character true false is easier. And so the main way that you change variables to some other data type is as dot whatever you want to change it to. So we have as dot logical. Here, I'm making this to be, it's numeric with 1 and 2 in it, but if I want to make it like levels or categorical, I'll do as dot factor. We'll run that, see it again. Now we say levels 1 and 2, and now it's labeled as a factor. So if we remember our y here, over here, we can see it's numeric. We want to change it to character. We're going to change it to as.character. Run that. Now we have a parentheses around it. It's a character labeled as a character variable. And we're like, oh, don't want to do that. We actually want to keep it as numeric. And you could just go back to that. So an important aspect, or really what makes R kind of really awesome, at least to me, is the actual packages that you can download and upload and use with your analysis. So there are so many different packages, from data analysis, from data management, from plotting to different analysis techniques. So like if you want to do a logistic regression or a linear regression, there's a package for that, or survival analysis, there's a package for that. Data management, there's so many different data management packages that you would want to use. Plotting, there's so many, and if you want to do really special things, there's just so many different packages that you can use. When you download R, basic R is already uploaded, so it does very basic things, basic data management, basic analysis like t-test, chi-square test. So for more advanced analysis, more advanced data management, you will want to download some packages. To install packages, you're going to use this code, install.packages. You have the parentheses and then in quotations, whatever package that you're going to use or that you're trying to install. You want to make sure that it is exactly how the package is titled. Again, case matters. So if tidyverse actually needed a capital T and I didn't include that, it wouldn't work. So I'm not going to install tidyverse because I already have it in I've already installed it. But you could also go here to packages, and any one of these are already installed, sorry. So if you want to load the packages into your script, into your specific program, this is sort of the first thing that you will need to do when you're doing your script, when you're coding, because a lot of the time, a lot of the code that you're doing, any of it is going to be related specific to some packages. So if you don't have these packages loaded into R, it's not going to work, right? So if you don't have, for example, if I didn't load this table 1, I wouldn't be able to create the table that I'm trying to create because it's not included. So once you've installed a package, you want to now load the package into R, and you want to use, it's simple, it's library, and then in the parentheses, you just put the name of the package. And so this you want to keep in your script, in your program, that you'll save on your computer and come back to. This is always going to be the first thing that you're going to do because this is going to allow you to kind of do all of the amazing things that you would want to do in R. To install the package, I would actually kind of do this within the console because kind of whatever you do in the script, you can do in the console. but it's just not going to be saved. So you don't need to install the package every single time you run your code. You only need to install it once. So I would actually recommend actually doing it in the console. I'm not going to put it in there because I don't want to download it because I already have it. Um, so here, these are 3 packages. So you just highlight it and then run. You could also pick one in here and you would just click it. If I wanted to do anytime, it runs it for you. I don't recommend using it in the packages because, again, if you need to use this going forward and need to come back to it, you wouldn't know that you uploaded and loaded this anytime package. So again, make sure you list them here. Tidyverse is an amazing package for data management. I'm not going to get into it here, but at the end, I do have some code on how you can do all the code that I do later on in Tidyverse. This table 1 package is a really simple package for how to create a table. And then I also wanted to bring your attention to this looper date. One thing I didn't really talk about is that dates are difficult to deal with in anything, in SAS and R and whatever. But with our Looper Date is just a really great package on a bunch of different ways how to transform dates and times into usable variables. So keep that in your back pocket. The great thing about R is all of these packages have extensive information online through CRAN. Also, these are very common packages, and you'll find so many resources online for this. And so if you want to get help information on a package or a function, you could just use this question mark and then the name of that. So for example, that package. So I can do this down here in the console. I'll click enter. And up here is just going to be what is Tidyverse, description of it, and some more information. Summary is a function that we're going to use later. So this is basically saying what it is. So this is just a generic function to produce result summaries of different variables or even models. And the great thing about this over here is that if you're like, I don't know how to do it, or I don't know how to use it, they give you examples. They give you what all the arguments within the function that you could give values to, as well as like what the default is. And again, a lot of examples at the bottom. So I use this help all the time to kind of, if I forgot how to use something or it's not working, I might go look at this this documentation to see like where I made a mistake. Okay. Next is I want to discuss what our example data is. So the whole idea here is that we have met with an investigator and they're looking at the relationship between multiple variables of mothers and babies from a maternal health study. And we want to answer the research question hypothesis, but first we need to clean and manipulate the raw data source so that the data is usable, because in the form it is now, it's not really usable. You received a data dictionary as well as the data file. So here's just a bunch of variables within the data set. We have ID, weight. This is infant's weight in grams. We have the race of the infant, whether or not the infant is a boy. So it's a yes, no. Usually in coding, 0 is no, 1 is yes. So marital status, the mother's age, mom's smoking status, number of cigarettes the mother smoked per day, mother's weight gain during pregnancy, the education level of the mother's height, and the weight prior to pregnancy. So it's the key points to remember in whenever you get a data source is absolutely do not make any changes to the raw data set. You want to leave it alone and save it in a folder that says raw data. This is the data that you're going to read in. And this is really important because say you make a change, but nobody else knows that you made that change. And say you left the institution or, you had to go out on leave for whatever reason. and they get new data and then they try to use your code, but they can't because you changed something in the original data. So this doesn't make it reproducible. So you want to make sure whatever you're doing is reproducible. You don't want to be the single point of failure. So do not make any changes to raw data. Now, once you read in the data, you can make any changes and then save this, as a working data set or their final clean analysis data set in a separate folder. Something I also don't like to do is I don't like to say we have this mother's weight, so mom HT. If I'm going to do something with the mother's weight, I'm going to create a no variable. I'm not going to override the raw variable that existed, because maybe in 2 or 3 weeks I need to do something different with this variable. And if I made a change to it, I can't undo it. So I always like to keep the raw data variables as they are, and then make any manipulations, and then I can remove them if I don't need them in my final clean data set. All right, sorry for the back and forth. So we're going to come back to our R. Do we have any questions so far? All right. So you can import data 2 ways. You can come over here underneath your environment, say import data. You can pick these different types. You could click here, browse, find your data set, click open, and then it'll import it for you. Again, anything that is not reproducible, I'm not a huge fan of. So this is how I recommend importing files. So if you have a CSV file, because usually data comes in some form of an Excel. So when you get the file you want to see, oh, we have a question. Yes, what is your question? Did you install the package? Because you have to install the package first. Elizabeth, I can help you after if that's okay. Okay, perfect. So to load in the data, so you want to check when you get the file. It's usually an Excel file, whether it's a CSV or .xlsx. So great thing is that you don't need to upload a different library or a different package. For CSV, this is already in basic R. So you're going to do read.csv. And so the first thing that you're going to put in is the path. So this is sort of all of this right here, all of this code, all of this writing is the path on your computer that exists or on a shared drive or whatever it is. And then this last part is the actual, data set name with .csv. And remember, it's in parentheses and quotations. If you're like, Samantha, how do you even get all of that? Well, I will show you. I'm just going to share my whole screen because that makes life easier for us. So basically, can you guys see this list? If you click, so I want to do this birth weight, CU data week, you're going to right click properties. And then right here is the location. So this is that full location that you have. And then this is obviously the name of the data set. So I'm going to copy this for you really quick to show you when you put it in. The big difference that you can see here is these the slashes. You have to change them to the other way. As you can see here, when you copy and paste it from that properties, it's this way, and you want it to be this way. That's why I want to copy and paste this for you, because it's super weird. But that's just an easy way to be able to load that data in to know where the location is. This is basically telling this is where to kind of pull that data. So we run it. So now we can see we have this data frame. There are 5,000 observations and 12 variables. Great thing is that you can just click this And then this gives you the whole data set. So I always recommend once you import a data set to just view it, see what it looks like. We can already see here we have some missing in this mom height variable. But yeah, we have all of that data. So this is a way that you can just view the data that you either have created, the data set that you've created or imported. Now, if you want to do Excel, that's an XLSX file. You do need the library read Excel. And then the function is just read _ Excel. And then again, it'll be the file path and then the name with XLXX. Okay. So now we have our data imported. Now we want to look at the data to see how we want to transform it. So one thing that you can do is just do this summary function, which we kind of looked at before, and just put in that data frame, right? Again, I also recommend when you label your data frame, make it something small and easy to remember. You could also make it like data frame maternal health or DF maternal or whatever, if you want to make it more clear what data set, especially if you're bringing in multiple data sets. But again, make it short because you might be using that a lot. So just if you could do a general summary of the whole data frame, so you can see down here in this console, all of each variable, and it basically treats everything that you put in that's not a character as numeric, right? So, ID is a numeric variable technically. Weight is this numeric, so we have min, max, but you can see married we know is a 0, 1, but it doesn't, here we can see it's not labeled as a category, right? It's just labeled as numeric. So that's something that we're going to have to work on and change. We can't really get any information about race because this is a character variable. And so again, this just gives a good overview of what this data looks like. You can also look at individual variables and get a summary of that. So to do that, again, we have this command summary. Now to look at the specific variable within a data frame, you want the name of the data frame. So for us here, it's DF. You use a $sign and then the variable name. Okay, so here we're going to look at the weight. And so here it's very similar to what you see before, but it's down here, min 240, max 6350. So remember, this is the weight of the baby in grams. So this is also a really great way to see, do these numbers make sense? Do we have any huge outliers? I remember I did this once with BMI, and I had a BMI of 1,000. I was like, well, that's not right. So this is also a good way to maybe even go back to the PI, or if it's your own data, kind of dig in to see why are these variables so big if they're not supposed to be, if it's outside what you would expect for this clinical information. Because, if you are putting data into REDCap or anything, there are human errors, so sometimes that happens. What I also wanted to show you guys is why uppercase and lowercase matter. So let's just get going. So if I were to change this to a lowercase, it's going to come back that it doesn't exist. So saying link 0, class null, mode null, it's not there, right? So that's why you want to make sure you have the case is correct. Now, say we just wanted to see the first 5 or 5, the beginning of the variable. Head gives you the first 5 values of that variable. So we can see here, this is the first 5 in the data set. And then again, we can look at what kind of data object is this, and this is an integer. So for summary, if we know something is categorical, right? So we kind of already knew this with summary for the race, is that we're just going to get length 5,000, class, character, mode, character. That doesn't really give us that much information about the variable, but we know that it is a character, or it's a level-based variable. So what you can do is you can add in this additional function called factor. So this is just basically telling our, this is a categorical variable, or this is a level-based variable, and we want the summary of those levels. Unfortunately, summary just gives you just the frequency, so you don't get the percentages in this case. You can use different functions to get that if you need it. So we can see here all of our levels, but then we see we have this blank, blank level here. So it's not labeled as anything, which we can make the assumption that this is missing, but it's not coming out as missing. It's coming out as blank category. So that's something we're probably going to have to fix going forward. Because if it was missing, so if we're going to look at mom weight, well, it'll say something here as NAs. So we can know here in mom weight, we have 81 missing. So that is not, okay, well, then we have that missing. So this should be NA at 127, but it's not. So that's something that we're going to have to change down the line. So this is something I recommend you do to kind of like discover your data, to kind of understand what it looks like and what you would need to change. But say you just want to kind of know like how many are missing. You can do, there's a sum function. So this is it's adding. And then is NA means like, how many, is this missing? So this is basically saying how much is missing of this variable. So you can look here, we kind of already know here, this for race, it should be 127, but we'll see because it's not listed as missing, it'll say 0, whereas we still get that 81 that we see here for the mother's weight. So another thing that you could do is create a table to kind of just do an overall view of your data. So if you want to know what the different arguments within this function called table, you can click here. This is the general, this is what we're looking for. So here, so this is gives the package, and then this is the function. And then this gives what you're supposed to do. So here are the different arguments that you can use. So X, data, overall, all of these things, whether you can include it or you don't have to, you can see that I didn't. This explains what all of these arguments are, what the defaults are, and then here's some more like examples on how to do it. So here we're kind of doing something called no stratification. So we're just sort of looking at everything. So you're going to do a tilde, put in the factor for any variables that you know are categorical, or else it's going to treat it as numeric. So we have race, married, mom weight, mom height, weight, factor of smoking. So we can run that table, and then you can see here. So again, what we already understood is that there's this blank for race. We have married, looks good. We do have some missing in mom weight and mom height, but we can see what the mean and standard deviation is, with the median, with the min and the max for all of these. And so, okay, now we have a little bit of a general idea of what our data looks like and how we want to transform it. So there are so many different ways that you can do this. I'm going to give you some kind of basic ways to transform and change variables or create variables. So the first one that is very common is a function called if else, and it is literally what it sounds. It's like, if this is true, this is what we're labeling out, else it's something else. So here I want to create a yes, no for whether the child or the infant had a low birth weight. So what I know, what I've either found out from the clinician or whatever, is that any child or infant that has a birth weight of 2,500 grams or lower than 2,500 grams is considered to have low birth weight. So I want to create a new variable in my data set. So that's why I have to label my data set, put the $, low birth weight, and then this is how I'm creating that new variable. If else, so this is sort of your first command, right? I'm saying that if weight is less than 2,500, I'm going to label as 1. Otherwise, it's 0, right? So we can run that, and it did. And then we could do summary. We know this is a factor, so we want to make sure that's there. And then low birth weight. Okay, so we did it. We labeled 0 and 1. In this case, I would go and do a check, and I'll show you how to do that later on to see you know, did I do this correctly? I'm not going to do that, but I'll show you how you do it later. And then your PI or yourself, you want to know what the BMI is of the mother before they got pregnant. So first thing you want to do is make sure that the units are correct, and then you want to go find what the equation is. So in this case, it's 703 times the mom's weight divided by the mom's height squared. So you just want to make sure that the units are correct, which in our case they are, so we don't have to transform the unit, but that's also something you got to make sure. So say you did this, but the mom's height was not in the correct unit, you might get a really off BMI. So there's something else when you get the data dictionary that you know what unit everything is in so that you can be able to do these things. So I ran BMI, and here's the summary of it. We have 154 missing, and then here is that general summary. But this isn't really helpful to me in my case. I don't really want to know just the number of the BMI. I actually want to put them into categories. So another really useful function is something called case when. I use this a lot. You can also use case when to do this if else statement as like this categorical one as well. So essentially, case when is that you can use multiple, make multiple categories. So here I want a BMI of less than 18.5. I'm labeling this as 1. And then if the BMI is greater than or equal to 18.5 and it's less than 25, so basically 18.5 to 24.99999, this will be labeled as 2, and so on and so forth. And I decided I actually want my missing to be its own category. So I don't want it just labeled as missing. I want to label it myself as missing, and I want it included in the variable. And so I'm saying is NA of the variable. I'm now putting it at its own category. So here we're going to run this, and great. We got our different categories 1 through 5. So this is something you could do up here, but I want to check it. So you can create your own data frame with the function data.frame. And then you just list out all of the variables that you want to include. You want to make sure that they have the same number. It's the same number of patients or rows within each of the variables, or else it won't work. And then I always like to label it as check. So it's easy for me to see that this is I'm checking to making sure that my code did what I thought it did. So here we'll look here. Okay, look, we can already see first off our NAs are 5s. So cool thing when you just click here that's ascending and descending, that's how you can label it. And so let's just go here. So we want to basically be 18.5 and lower to be 1, and 18 or 8 below 18.5 to be 1, and above 18.5 to be 2. So this is tedious. You don't technically have to do this, but I do it because I like to make sure I'm doing things correctly. So right where it changes, we can see 18.47 is a 1, and then at 18.5, we go up to 2. I coded it right. Awesome. So coming down here, another way that you can use if else is if you want to assign this as missing, right? So we had that race category that was, we just had one of those categories, which is just blank, and it wasn't, because of how the data pulled in, it didn't count it as missing as an NA. So here I'm creating a new variable called race cat. So if else, I'm saying if this equals. So again, in R, you rarely, if ever, just use like a single equal sign, unless you're working like in tidyverse, which is a within that package. But if you want to say something equals something, you use 2 equals when you're creating a variable. Thank you. Okay, so here I'm saying if this is blank, right? Because it's just a blank, so I'm just going to put, and it's a character variable, so I'm putting it in quotations. So anything that's character or string, you're going to put in quotations. So I'm saying if this race variable, if it equals blank, then we're labeling it as NA. Otherwise, we're not changing anything. We're leaving the variable alone, so we're just saying it's DF race. So we made this new category. Let's run it. Awesome. Now it's labeling it as missing. That's exactly what we wanted to do. This is just really quick. Something that you can do is create dummy variables. So for a lot of times, sometimes when you're doing analysis, you want to look at like just people who were in the Black category or white or Hispanic or Native American or Asian, right? So you can make these demo variables where it's like, if this race category equals Black, it's 1, otherwise it's 0. And so you can do that for every single category within your categorical variable to make these dummy variables. So I'm just going to run this really quick. And so cool thing you could also see here is that the number of variables we have is going up. That means that you're actually creating the variables as you're going through. Okay, so now just having 1 and 0s isn't super meaningful. You know, when we made our BMI category, we just put them 1, 2, 3, 4, 5, which isn't super helpful. You can make these characters within here. So I could have labeled this as low birth weight, normal, obese, severely obese. I forget the levels. We have them down below. Or you can do it the way that I did it. I've done it both ways. It doesn't matter too much. But we can see here, class variable when we did the low birth weight, this is a 0, 1, it's numeric, but this is actually a categorical variable. So we're going to use the function factor. So this is going to say, for this variable, we're creating a level, right? So if you want to know how to do that, we're going to do question mark factor up down here in the console. You can also do it in a script, but I don't want to save it. And so this kind of gives you what you need to do. This is going to be what the character is, the level and labels. And then if you want to exclude missing, or if you want it ordered, or all of these things. And again, arguments. So this kind of gives, okay, this is how you should use this function to the instructions, right? So here, this is saying this is the variable that we're working with. Here are our 2 levels. You can see this C again because we have more than one level. And then these labels, we see this C again because we're labeling more than one thing. So we're saying if it's 0, it's normal weight. And if it's 1, it's low birth weight. And if I were to switch this as 1 and 0, 1 is now saying this is normal weight and 0 is low birth weight, which is not how we coded it, right? We said low birth weight was 1, regular birth weight was 0. So order also matters in these. So you want to make sure that like the level that you're labeling the level correctly. So here we're going to do that. So we can summarize that again. And now, because it's already as a factor, we actually don't have to put factor when we want to do the summary. So, and then you can see here, it's labeled normal and low. And you can see here, I did low birth weight cat. So I know I have like a numerical low birth weight and then the low birth weight cat. So we could do this again with BMI, right? We have underweight, normal weight, overweight, obese, and then missing. Our smoking is yes and no. So we could just run all of that. I think I was playing with this. So here we're just gonna factor all of that. And then, okay, so kind of the goal of kind of any report is that you want to give kind of summary information. And the first thing that is the table 1. So there are so many packages and so many different ways you can create a table 1. What I'm showing you here is a very, very basic. But again, you want to actually have, like we have labels for the values within our variable. We also want to label the variable. Otherwise, we're just going to have something, you know, if we look at our viewer, we just have mom weight, mom, you know, the actual variable name instead of a prettier version of this. So for example, low birth weight, you know, low birth weight less than 2,500 grams, or I can label it the category low birth weight. The race cat is race. And so it's just, you're going to do label the variable that you're trying to label with your arrow. And then your, however you want to label it, going through. And then, so now we'll do this table 1 again, and now it's just a lot prettier. So now we have that missing race. Oh, you know what? I didn't change the white and black dummy variables or any of them, so I would want to go back and label these as no, 0 for no, 1 for yes. We have the general, mean and standard deviation of the low birth weight, which we actually don't want. And then we have normal weight, low birth weight. We have the body mass, the mean, the standard deviation, the median with the min and the max, how many we have missing. And then we have all of the categories. And then we have the mother smoking, yes and no. So this is just a really great way to kind of summarize your data and then see, again, anything that you would want to change, and then you could show it to either yourself or your investigator, so then they can also kind of make decisions going forward if anything that needs to be changed or anything that like doesn't make sense. Because like I'm not a clinician, and sometimes maybe this looks normal to me, but I show my report and they're like, that's a little too high, or this isn't, this is too many, it shouldn't be this high. So, we love tables. And then, just within this, you can also stratify it by disease status or treatment status or any of those. So you can also look at that comparison, which is really great. And so if I want to create now this clean data set, you can either just create, just export the data frame, or if you're like, you know what, we didn't really do anything with mom age or mom weight gain. So here I'm going to select the data set and I'm going to remove these variables. Or you can just say, so that's why I have this negative here with the C and then the variable names in there. Or you can say like, these are just C, the ones that you want to include. So here I'm removing it so you can see we have 2 less variables. And then to write the export the data, we write .csv, the data set that you want to export, where you want to export it to. So this is the path, and then that you want to label it yourself, right? And I'm exporting it as a CSV, but you can export it as an Excel, as a SAS file, as kind of anything, as a text file. So you can export anything. You can also export things as like PDFs or even JPEGs. And like if you have like a figure and you want to export it, like you can do that as well. It'll just be a different function. So here we can do that. And if I were to show you this clean, it just showed up. It's now my new clean one. You can say when I modified it. So we have this extra code that you can look at later. So this is using Tidyverse to do the same thing that we did before. So you can see here how I did everything basically in one go, right? I did all of this data cleaning, everything that I wanted to do in one. This is something, it's really helpful because it kind of reduces how many lines. You can see everything all at once. It's just sort of, I can just run it once, but you'd still want to go back and check and make sure that everything is doing what you think it should be doing. And then again, you can use Tidyverse with these piping, and you could technically within Tidyverse be able to do both of these in one step instead of multiple steps like we did above, or even this 2-step here. You can modify and select all in the same. Like Tidyverse is really cool because you could do multiple different steps in one step. So it's really, really cool. Order does matter though within this as well. Okay, are there any questions? So
Yes, I have a question if you don't mind.
Of course.
On the if and else statement, what is that? Is that like a tilde? Why not comma? I thought I don't know much about R, but when I saw the codes, I saw like a tilde. What is that symbol on the coding if else statement?
Here?
Yes, like this one, like 25. Let's look at the BMI, BF
Yes.
data frame.
Oh, this tilde? Oh, yeah. So again, this is within case when. So if else has commas, and then within case when, this tilde is representing that if the BMI is less than 18.5, this tilde is saying this is now going to be level 1 category. I don't know why it's a tilde. I didn't make the function. It's just sort of what that function requires. And so if you want to know, exactly what is needed when, so you can see here, we could do case when, and it'll show you examples. And so you can see here to be able to do it, to label it as that level, or for us, we did this as 1. Here they did phys biz. You use the tilde. So it's saying if BMI is this, tilde, it's 1. So that's how we made that category.
Okay.
It's just the syntax within this specific function.
Thank you.
And so that I think the reason why we don't do commas here, because you do have a comma at the end, right? So if you're doing multiple levels, the tilde is representing what the level is. The comma is so you can do multiple levels and how you're going to label each level. It's just whoever created the function, this is the syntax they wanted to use specifically for this. So the tilde is just how you label it, I guess you could say. So it's 1, or if I could technically do that also, you could do that as well. But the tilde is assigning that
Mining.
value.
Okay,
Yeah. Does that make sense?
Yes.
Perfect.
Okay.
Any other questions?
I actually do, but I don't want to take up your time on that table 1 because I have never seen that, but I am totally new with R.
Well, we have 15 minutes, so
Okay.
we have plenty of time. Karen, no. So if you're not at the soiree, you still get to, and your name is picked, you still get to win. We're just going to announce it, and then you'll get an email from us on either Friday or Monday. So spaces, it depends. So I hate to say this, but it sort of depends. So I would say if you're meeting between here, like, no, you could do a bunch of spaces between these two, and it doesn't matter after the comma, right? So if I'm doing the label, this is what I'm labeling a comma, and you could do a bunch of spaces. That doesn't change anything. If I put a bunch of spaces in here, this is how it's going to label it with all of those spaces.
Okay,
So
it's issued between those quotation points,
for
but
the
if it's
quotations, yeah,
okay.
but you don't have to. And when you get into more advanced coding, spaces can matter, or like tabbing in. But in this case, if you could put a bunch of spaces, I wouldn't recommend it just because then it just gets really big, but like 1 or 2 spaces is totally fine. And then, yeah, and this is something I learned. The variable name, if it's coming into you and it has spaces at the end, if you don't include those spaces, it won't, it is so confused. It won't like, it just doesn't, like, the spaces matter if it's within the variable name. So that's why I would recommend not putting a bunch of spaces there, like, because it's more room for error later if you want to call it back later or transform it into something else. Also, just FYI, on the rest of the presentation is resources that you can go to. So the one thing I really, really love about R is there's Stack Overflow, Geek for Geeks, just a lot of places where people are like, for example, if you had a question like how to use case when to make variables, like you can find a plethora of information. I feel like as statisticians or as coders, Google is your best friend. So even if I've done something multiple times, like I've made this same not table figure, but I sometimes forget. So I'll just Google it again using something called ggplot. How do I change the x-axis again? So there's always example code. There's so many YouTube videos. There's so many tutorials. There's just a lot of free stuff out there for R. That's one of the reasons why I really like it, because if I don't know how to do something, somebody somewhere knows how to do it and posted about it. So any other questions?
Perhaps you can help with the table one now. What do we need to install to make table one works?
Okay,
When
so
I hit the library table one, it just wouldn't work.
yeah, so the first thing that you have to do for that, so what you would want to do in the console, you want to do install dot packages parentheses table one. So first you have to install the package onto your computer and then you can call it. So you only have to install a package once with an asterisk, I'm going to say, unless R updates. So if R updates or the package updates, you're probably going to have to reinstall packages. Also interesting, sometimes one package requires a bunch of other packages that you also have to install for that to work. But yeah, so the first thing, if you're going to use a new package, you have to install it first. So you can use this code. I'm not going to do it. You would just have to click enter. Because if I do it, then it's going to load it again. And it sometimes takes a little bit. So for R, I've never dealt a lot with lagging issues, if I'm being honest with R, but I think it really depends on how big your data set is and what you're doing. So if you're kind of doing like basic data management that we're doing here, you're not really going to see. But if you're going to do something like a simulation, then that is going to take a long time. So, for example, for my thesis, I did a simulation and it would take 2 hours to run the simulation to get the results. That's not really a lag. That's just how simulations work, is that usually because especially if you're doing a lot of simulations, it just takes a long time. But I've worked with lots and lots of rows, thousands of rows, and I have never really dealt with a lag. And a lot of that could also be what is capable on your computer that you're using. So if there's not a lot of processing power, you could also experience lags within that as well. So sometimes it's R, but sometimes it might just be your computer and its computing power, not powder. But you could see here, this was, 50,000 observations. I mean, it's only 21 variables, but there was no lag. It went by really quickly. And, again, the reason why I like R over doing stuff in Excel is that this is reproducible. And I forgot to say, but if you want to do code, you can see how I did comments, but to comment things out, you just have to use the pound sign and just put all the whatever information that you're going to include. Any other questions?
Yes, I kind of do waiting until somebody else asks question about the factor. You put that C. Is it just you only use that for categorical data, correct? I assume.
When you have, so you can see here, this is numeric.
Okay.
If you have more than one, you use C.
Okay, so it doesn't have to be characters or categorical. Or categorical, it could be numeric and like string, right?
Yeah, and again, there's so many different things that you can do in R, but say if you want to you can use C if you're just wanting to include columns, or you just want to look at this, or you just want to pull in this specific rows, or C is just used to if you have more than one.
Thank you. It's clear now. Thank you. And
Yes.
table is working. Thank you so much.
Awesome. I'm so glad that it's working.
Thank you.
Any other questions? So I think some people have left, but I'm pretty sure in the chat, Lauren had put in the survey and raffle entry. So please fill that out. That also is really helpful to give feedback, like what you liked or didn't like about the presentation. We do look at these and kind of make edits based on your guys' feedback. We also want to say like what you would want to see next year at CU Data Week. You know, if you see what we've done and you're like, you know, we added something something about Python. So we did an introduction to Python because people in the feedback said that they wanted that kind of information. So please, you know, even if you don't care about the raffle, we really want the feedback. That's why we're doing the raffle, to get you to do the attendance and fill out the form so that we can get your feedback. Oh, another question. Oh, Lauren put it in again too.
Yeah, and I'll also just mention that after CU Data Week is over, everyone who had registered for the seminars will get a link to our website where the recordings of all of our presentations will be posted. So if you want to come back to the presentation, that will be available in about a week.
Thank you so much for coming. I hope you learned something. I hope this was educational and helpful. If not, fill it out and let me know how I can do better next time. Are there any other questions? Awesome. So we'll just stay here. And if people want to stay and ask questions, maybe when there's less people, we could do that. If not, thank you so much for attending, and we'll hope to see you at the next one.
Mute. Okay. Could I just ask a quick question again?
Of
So
course.
if you download all those packages, which I have been doing the whole day today, I'm learning online, just kind of trying.
Yes.
And you do not have to install packages all the time, right? Because I just run it until you said it today.
Yeah, so you just essentially you really only need to install packages once. And again, I put like an asterisk, unless like there's an update of the package, then you'll have to install the newer version of the package. Or sometimes when you update R, because you know R comes out with updates, I think like every 6 months or maybe every year. And so sometimes you might have to reinstall a package because you've updated R. There's a way that you can like save your packages so it makes it easier to upload. But once you install a package and you're not you haven't needed to re-upload R or update R, the only thing that you will have to do coming forward is do library parentheses the package that you're interested in. For every new script or every new code chunk that you're doing, like, you know, you need to have the library should be the first thing that you put in there, because these are what you're using to run your script. So any new script, you need to have whatever libraries that you're going to use.
Thank you. This is very clear. I don't know about other participants, but I feel that way because today I learn a lot on my own, you know, online, and I just play on it and hit as you're going through, and I look at it and I thought I like it. I love it. So thank you so much.
Of course, I'm happy to help.
So I guess we are done for today, and maybe a suggestion, you might want to just give opportunity for the people to hit it, like run it at the same time, or give them a minute or two, because I'm running it as you are doing it. I'm running the data and I set the directory because I learned it today. That's the only way, because I learned it today online. So I ran it, because if I don't run it, I won't be able to go back.
Okay, that's a really good suggestion, and I will definitely, I might have to take stuff out so that I can give people time to do that, to go along, but I love that suggestion. Thank you.
And you can also tell the people like me, I will use your codes because I love the way you're breaking, you know, I work for like health, not health department, but Southern Plains Tribal Health Board. So we use health data. So I like the way you are making the example. Exactly, that's what I need. So I will tailor that. So that's my comment. And I think I'm done, and thank you so much. I look forward to the other classes then. And I will recommend this class. And I have 2 other epidemiologists coming on board. You know, I would like, they don't have anymore, right? Or in the spring, you have more classes. Is that it?
We do this. It's okay. CU Data Week, we do every single beginning of spring. So this, but they have access to the recordings everybody has access to the recordings, and it'll be posted probably early next week. And if
Okay.
you have all of the stuff, like all of the materials, you can share it with your people, and then they can follow along with the recordings as fast or slow as they want.
Thank you so much. You guys have a
course.
great evening. Thank
You
you.
too.
Bye.
Bye.
What does if else mean?
So if
You went
else,
you went so quickly over it. I didn't
Sorry.
understand what it meant.
here, I can share my screen again. So if else is a way to create a sort of two categorical variable. So if is like so sort of like the case when. So we're trying to create a new variable based off of another variable. So here if else, so it's saying if this, so if this weight is less than 2,500, we're saying it's a 1, else it's 0. That's just that. So it's saying this is sort of your if part. So if this is, so if weight is less than 2,500 grams, then it's 1. Otherwise, or else it's 0. Another example that we did was the black, right? So this if else, I use if else a lot if I'm kind of just doing a like if I want to create a 2 categorical variable. So I'm saying if else, so if the race cat equals black, then this black variable here is 1, otherwise it'll be 0. So essentially, if we look at this, so if we do the summary of the race cat, right, this black category is going to have 7,136 as 1, and then all the other ones as 0, right? Because we're saying if this race cat equals black, we're labeling it as 1. If it's not black, then it'll be 0. So if I were to summary this, this black that we already did, you'll see the summary. We have black here is 7,136. So 1 is now 7,136. Everything else is 0, except for our missing is still missing.
Why do you need to put in the word factor?
Oh, so because if you didn't, when I run the summary, it's just, because I already did it before. So factor you need to use, unless you've already created it as a factor, which we actually already did below. If I were, because we already did everything, and down here, I already factored all of this. Factor is saying that this is a level, right? If you didn't put it as a factor, then it would just count it as numeric. So it would just give you like a minimum, a maximum, the median, the mean, and that's not helpful for this 0, 1 categorical variable that you created. So when you know something is categorical, you want to put and you want to just a summary of it, you want to put factor in front of it. So coming back up here, I showed this a little bit up here. So if I did summary of race, we can see here down in the console, it doesn't give us anything, right? It's saying its length is 500, the class is character, and the mode is character, but that doesn't give us any information about this variable, right? We want the frequency. It's because it's a character variable, and so we can put factor before the variable that we want the summary of. And so if we run that, now it tells us the frequency within each category. And when you do this table, right, if we didn't, so for example, we didn't do anything with this married category, right? So if we look at this.
So here is another one that I couldn't follow. You frequently put in these things, but you don't tell me what the structure is of the different things. So you did this table 1, you put different things in it, but I couldn't figure out quickly enough how you make that structure.
Okay, so I did show quickly because I think I put too much in here. But so the table one, this is the function, and so these are the different. This is how you put in all the things that you want to look at. So the arguments within this. So the first thing that you put is that you have to put this tilde to create the table. And so then it's just these variables, all the variables that you want in the table, and then a plus sign between each variable. So it's like adding all the variables that you want in this table. So you're right. I went too fast through this because I was running out of time. So I apologize. And then the next thing is that you have a data equals. So this is saying the data frame that we're pulling this from that we want to make a table is DF. That's why, you know, if you look up here, whenever we're calling a variable, we put the, what's it called? The data frame and then the $sign and then the variable name. But here, you just want to say, this is the data that we're working with. And so the reason why I put factor here in front of them is because I know these are categorical and I haven't done any kind of transformation yet, because this is just preliminary. I'm just looking at the data. But I know that they're levels, and so I want them in the table to be a level, right? So these are all the variables that I want to look at. I know that married, race, and mom smoke are levels, are categories. So that's why I put a factor with the parentheses around that category or that variable. So here I'll show you an example, right? So here for married, I said factor, and now it knows its level. So we got the frequency and the percent. Now I'm going to take out the factor so you can see why this is important. So if I took out the factor and I just put the variable as married and I run this again, married now has a mean standard deviation and a median and with a min and max. So now it's just treating it as a numeric variable, but it's not. So that's why you just put a factor in front of it. And then, so now we get it's correct. And so then if you come way down here, as you can see, I then just created, using this factor, I created a new variable. So now when I make the table again, I don't have to put a factor in front of anything because I already fixed the variables to now be factors up here.
When at some point you clicked on something that was just too quick for me to see, where it showed you what the table was in the upper left box. Where did you click on it to show what the table looked like?
This one right here, or my cursor?
This was a while before.
I think, Samantha, when you clicked on the data frame in your environment to get a new tab.
Okay, yeah. So what you can do here, so you see how we have all of these different, so we have up here in the environment, we have data. So you can see here that these are all different data frames. If you just click it, then the data frame just shows up here. So we can click all of them, and they will all show up as different tabs. So here's our script, and then here are our different data frames that we've created or imported. So this will be
That's
really
what I didn't see.
Yeah.
It went blisteringly fast for me.
I will slow down next time then. I think I still need to take a little bit more out. So I will do that.
Yeah. Thank you. I think that I got a little book that's called Basic Introduction to R, and I think I need to go through that very slowly.
Yeah, there's so much I wanted to tell you guys and teach you guys how to do, but it's even we increased an extra 15 minutes and gave this 15 minutes of but yeah, so definitely it's recorded, and so we're gonna post this next week so you can go through it again and maybe go down a little slower and then kind of do it with me as I go through and do all of these different things.
Thank you. Thank you. I've used for the last 20 years after I got statistics in my business class, school class in SPSS. I've been using SPSS a lot, like almost every, and it does most of it, but nowadays I need to ultimately move to R.
Yeah, I feel the same way.
The big part does that I haven't been able to do in SPSS is some of the plotting is better in R, that I just cannot do.
Some of the plotting is better in R. Yeah, R is,
Virtually all the statistics I've seen people do in R, I can do them in SPSS.
yeah, for sure. For my master's, my MPH, I worked in SPSS and SAS primarily. And then when I came here to get my master's in science, both like data scientists and data biostatistics, either use SAS or R, and R is just used a lot. And even Python is also used. So
All right.
yeah.
Thank you.
Thank you. I'm so glad that I can help.
Bye.
Bye. Delaney, did you have any questions?